Okay, so hello everyone, and welcome to I'm going to review one of the report that coming from the Machine and Mechanism A mini projects from 2025. You know that in my channel I have two examples from 2024, but now I'm going to show you the top scorer from the 2025. First report I'm looking at scored 36 out of 40. Again, to have a look again now. I wasn't the person who marked these reports as far as I know, but anyway, we're going to have a look to see what they did well and where did they went wrong. So the first report, you can see that we have the cover page, the mini project, the year, the group number is very important. Remember that one of the team members need to submit do the submission. It's group submission, but the grade should be individual. I mean, for example, if Christina he did better than Kaja, then Christina will have higher mark than Kaja. So that's the concept of the work. We can see here that we have the link for the video presentation, as we did with the subject of manufacturing. You remember that you can upload the video to the YouTube and just put the YouTube link here. Use YouTube. Don't use the Google Drive, please. Because again, to try to mark the Google Drive, through the Google Drive, we need to have a permission from you. And this will take time, and maybe you're not going to be aware about that. And you miss your opportunity to get marks for the video presentation. We go to the table of the contents on the second page. It's about the group number or the table of the contents. What we have there, and the problem against the page. So we can simply click on that and go to the work. Now, one of the most important thing we need to have is going to be on the first page about the team contribution and the reflection. Who did what? Okay, who did what? So we can tell that your work is better than your colleague. Okay, so just saying here that Christina did the problem 2 and the MATLAB Virtual Lab 2, while Kaja did the problem 1 and the MATLAB Virtual Lab 1. The reflection is about what the student got as an impression from the project. I like what they done here. I mean, they put as sections the achievement from the project, what's worked, what didn't work, what will you change if given another opportunity to do the task. Okay, so well, wait a second. I think that for getting some components which made the hand calculation answers much harder. Well, yeah, we explained that. So if you just watch the video, you'll understand what we need to do from you. Kaja did the same thing here for his reflection or the impression on the project. Now we go to the first section, which is going to be about the problem number 1, which is the same thing that we had this year. It's about the spool and the truck, spool on truck bed. You know that you will need to explain to the reader what you're intending to do here, what the reader is going to go through. So you will find out in the second example we have here today that the student just wrote down something like 3 lines describing the problem. It's not acceptable. You need to do something professional. So here, I think it was Gaga. So he explained what the problem is. 500 kilograms for the mass, the radius of gyration given. The truck has an acceleration. The spool assumed to be rolled without slipping in the first scenario. Normal reaction forces on the spool, linear acceleration of the spool at its center, frictional force between the spool and the truck, and the spool angular acceleration must be there in mind. So that's what he just explained, what we have been given and what we need to get. I like that because he did the sketch by himself. I have a video somewhere on how to sketch using the Excel. Okay, and maybe again to repeat that for you by tomorrow, make a short video on how to sketch using the Excel and how to take that to the Word document. Okay, so you can see that he sketched that by himself. It's much better than take a snapshot and put on your work. More effort, that means you deserve more points. Okay, so that's a free body diagram and the kinetic diagram for this scenario. And we did that in the examples, as you remember. Okay, the known parameters and the condition has been all displayed as a table. The mass of the spool, the rate of the gyration for the spool, track acceleration. These is something you can change. So that's what we call parameters. That will be your input. And according to that, you will get some output. The variable we are going to have are also listed. These are the unknown parameters and the required outputs. The variable name is the pipe mode of inertia because this will be calculated using both the mass and the rates of gyration. So this will be changed. This will be something to be calculated. Radius of the spool in meters, normal reaction on the exerted on the spool, the normal force, we have the alpha, we have the linear acceleration of the spool at the center, or the AG as we call it earlier, and the frictional force between the spool and the truck. So the formula for analysis, you can get all these formulas from the lecture slide. You can have them from the MATLAB code itself. Just type them. Please don't take a snapshot. Well, it's not that hard to type an equation. It's very easy to type an equation. So please put some effort to do that. So we coming here and put some assumptions for the scenario we have. Like first, we have the spool is rolling without slipping in the first scenario. No external forces than the friction act between the spool and the truck bed at the contact point. The friction is going to be static and sufficient to prevent the slipping. The truck has a constant linear acceleration. The spool has a uniform mass distribution, and the acceleration due to the gravity is going to be given by 9.81, which is the G value. The equation for the calculation has been listed. As I told you once again, that all these equations are actually coming from the code. Okay, so once again, we did similar example in the class. We reviewed that for the quiz, so that shouldn't be something new on you. If you would like to know what you are going to add in your report, please watch the video that I have on my playlist. The calculation of the unknown parameters and the required outputs, well, as you know, the I value, the K value, how to be calculated, the alpha, the acceleration of the center of the spool, the normal force, and the friction force. It's a good thing to number the equation, so you can say that, oh, this parameter has been calculated using the equation number 22. Okay, the final solution required for the output is going to be the normal reaction exerted on the spool. The final reaction was 4,905. The spool angular acceleration 3. The linear acceleration of the spool at the center is going to be 1.5 meters per second, and the frictional force between the spool and the truck is going to be 750. That has been done by calculation. This was calculated. So he put a certain values, as you can see here. He decided that the mass is going to be 500, the rate of gyration 0.5, and the acceleration was 3. Then according to that, we calculated the other parameter using the equation given to us in this list. Okay, now he's going to verify these values. He's going to use this value to verify the MATLAB is doing the correct calculation. So we run the code. You remember that you have to follow the steps that are given to you in the start here section, one by one. Okay, you have to run every section individually until again to have the parameter to be generated for the section after. Don't run the code from the beginning. So by doing that, you will end up by getting the same value for the N, for the friction force, and for the acceleration. That's mean your code is doing correct work because you use the calculation, the hand calculation, to verify that the code is working correctly. Now, after you're doing that, now you can change these values. You can change the inputs and get a new values for the normal force, the friction force, and the acceleration of the center, and the alpha value, because now you know that the code is doing correctly. So watch the video, you will understand what we are going to mean by these graphs and what we are going to mean by every output we have here. That was the presentation for the sections, how to plot the figures, what the meaning of the figures, what the output we are going to get from this figure, and so on. Okay. From my point of view, I think that many people will say, okay, now he just get that from the code. Yep, but he presented in very easy way that makes the reader to read it and follow it up in a good manner. So try to do the same thing. Now, modeling analysis of the MATLAB values. He described the MATLAB code first. Now he's going to do the changing. So this full angular acceleration, the MATLAB value is a 3, the manual calculator was a 3, the same thing with the calculation and the MATLAB value, very small changes, we send you 2 in thousandths, okay, and the linear acceleration the same, and the fractional force was the same. So just very brief discussion about what we have between both, and this should be okay. That was one thing, but I think that he missed something to be done after that. We are going to start with the same parameters. We can change the mass, we can change the acceleration, we can change the radius of gyration. So do that and get a multiple result. Let's say, for example, get 3 or 4 sets and make a conversion between them. Okay, you need to add that here. So once again, I wasn't the person who marked this one. If I get to mark this one, I think for this section out of 20 for this student, he deserves about 15. Okay, it's not 18 or 19, it's 15 for what he's done, because he missed the most important thing. If I get to have a code, I need to use that code to get a multiple iterations. No iteration has been done here. Just remember that. No iterations has been done here. Now we're going to the task number 2, when we're going to have the slipping. So, well, actually, the MATLAB code, or what you call the, not the MATLAB itself, the Simulink will tell you that you have slipping or no slipping. I don't know if you check the video, you will find that the Simulink code is going to have a circle that turn red if there will be slipping, green if there is no slipping. That means you need to change your parameter to check at what situation between the mass of 50 to 500, rate of gyration between 0.1 to 0.5, and the track acceleration between 0.5 to 20 will cause the slipping to occur. Not only changing the coefficient of friction. Usually what we do is that we fix one of the fix most of the parameters and change one of them. So I can change the mass. I can change, of course, the mass will be related to the coefficient of friction. So you can change the acceleration. You said that at 0.5 acceleration, there will be no slipping. If I get to increase the acceleration to 10, there will be slipping. Then in between them, you're going to have something like another 4 parameters, and see that at 2 there will be slipping, no slipping. At 2, at 4 or 5 there will be no slipping. 7.5 we're going to have slipping. So just go back a little bit to the 6.8, for example, and see if there is slipping or not. Then you will say that the critical acceleration is going to be this value. That's a good idea to make the variables change. I'm sure 100% that the student hadn't done that as well. So once again, he presented all the equations, which are once again from the code, and did the hand calculation for that and verified the MATLAB code. We can see here that we can slide these slides. I would like you to watch the video because I'm not going to explain this one here, to change any of the parameters that we have. Now, what is the thing that, okay, now how you can tell that changing the mass not going to be enough, because the mass and the I value, or the moment of inertia, will decide what the K value is. That's mean you need to calculate the I value for the cylinder, then you are going to know what the radius given to you, and every time you are going to change the mass, you are going to change the K value to be compatible with that mass if you would like to change the mass. Okay, because these two values are related. Remember that the K is equal to the under square root of the I divided by the mass. Okay, so the mass changing, the K should be changing. But for the acceleration, if these are going to be constant, and the constant friction is going to be constant, but the acceleration will be changed, then the situation will be changed. The output will be different. Okay, again, did the steps, that will be shown to you, and that's what I'm talking about, this circle. The green one means there is no slipping, the red one means we have a slipping. So you can keep changing parameters until the green will be turned to red. Then you are going to play a little bit within the range of y is changed to red. For example, as I said once again, at 7.5 meters per second square, you can find it's red. So you drop it down to 7 and see if it's going to be changed to green. If yes, then you change it to 7.1, 7.2, 7.3 until you're going to have the change in the color to be red. Then you will say that the critical acceleration is going to be the 7.3, for example. Okay, that's the description of the Simulink code. These are the outputs. Well, this is not fully shown. If you're going to have this graph, you will find somewhere here at the top, like the 4 arrows going to the different corners. So you click on this one, and this will maximize the view of the graphs. Do that before you get to put the graph on your report. Okay, you can see that it was describing the output of these reports, what's happening here, what is yellow, what's the blue, what the difference between them. It's all being mentioned here. And also it's mentioned in the MATLAB itself. Okay, I think that he changing the acceleration, which is the correct things to be done. Okay, so changing the acceleration is the correct one. No, wait a second. He changed the mass and he changed the K value. That's logic. Well, because the mass reduced, so the K value should be increasing. And yeah, that should be correct thing. So he keep changing that until the red light will appear. And this, I think that he explained that he changed these parameters and find what will be the critical value for the acceleration or the any of the parameters. Write down an analysis for that. Okay, and done. So you can see here that the range for the task number 2 has been done here. So in order to test the validity of the manual calculation values comparison to the MATLAB model equation, a set of the test input values for the known parameters were chosen within the given range of the task number 2. So he chooses these values and run the calculator, and compare between the manual calculation and the MATLAB output, which seems to be compatible as far as I see here. Okay, so in the table above, it's clear that the MATLAB engineering calculation align with the manual hand analysis of the chosen test case, indicated the validity of the Newton's second law, and the constructed equation for the hand calculation. So he said that the MATLAB model confirmed this spool is rolling without slipping when the Simulink measurement subfile is going to be checked. So the red is slipping, and that's indicated by the red circle. As slipping is determined to be false, aligned with the manual determination of the non-state step. Okay. So he gave the reason according to his understanding. Now we going to the problem number 2. I think I only get to cover that, okay, at least for today. So you can see that, well, remember that's done by the other student. So defining the problem once again is nice sketch, and given all the parameter will be changed, which is going to be the theta, the L, and the mass, of course, and the radius. Remember that we have radius and we have radius of gyration. Please don't mix between them. If you pass because you should know the difference between the radius of gyration and the radius of the cylinder. They are totally different. So the student described the situation we have here, okay, and what we are going to do, what the parameters of the interest we have on this scenario is already being listed. That's very good. The free body diagram and the kinetic diagram for both situations has been sketched, and the geometry, the theta, and this will tell us what will be the height and what will be the or the y direction, the x direction and the y direction for the displacement by simply analyze the triangle by knowing what the value of the theta. The known variables and the conditions has been listed in a table with the units, which is very good. Just don't forget that. The boundary condition of the angle, where the angle in which the pendulum is going to be swing forward and backward, is going to be constrained between the 0 and an appropriate value to be changed. The unknown variables and the variables of the interest for us, the unknown variables which is going to be calculated later is going to be the horizontal reactions force of the rod, and the Ry value is going to be the vertical reaction force of the rod, and then we're going to have the mass of the moment of inertia of the pipe, which is going to be the I. The variable of the interest that we have is going to be normal force for each time, the required frictional force between the rod straps and each time with no slipping, the angular velocity of the pipe or the omega, the angular acceleration alpha, and the maximum tension force in the strap, the T maximum. So the T actually is going to be found by finding the reactions, because the reaction on the cable and the X and the Y, the value of its resultant is going to be tension in the cable. Okay, so the equation also has been listed, which once again can be found in the code itself. Just give the enough description of each one. Okay, just don't put the equation as foreground that the people will know what you are talking about. The condition and the assumptions made for the no slip between the strap and the rod and the forklift tines, the rigid connection between the pipe and the strap rod, the system monetary, and the rest also assumed to have a certain value, the range of the swinging pendulum angle, the external forces, the gravitational acceleration, the mass of the strap or the rod has been neglected, the pipe assumption and the condition to be uniform shape, uniform distributed load, and we are going to consider that's going to be a thin-walled pipe, so we can calculate its value for the I. The conservation of the energy, because we're going to have change in the height for the pipe mass center of the gravity. Okay, so the equation we're going to use is going to be the KE kinetic energy, potential energy for the initial is going to be equal to the one for the final. Once again, the list of the equations. Okay, and do the hand calculation and compare to the results that you can get from the code. Well, that's very nice presentation. Very nice presentation, because it's going to be clear. Even if you're going to get all the equations directly from the code, but by presented that way, that will be very good work. That's when you put good effort to present your work in a very clear manner. Okay, so the final calculation equation is going to be for the it's not normal fraction. This should be the R and the Y. Anyways, it should give you the same answer. Okay, the MATLAB verification for the results, which has been done by both do the run for the simulation and do the manual calculation, and the answers should be compatible. So the task number 1 was deriving the equations of the motion to solve the problem by utilizing the Newton's second law, and the task makes the initial considerations to begin with, and the highlights of the goals to be programmed, where the M is going to be determined by the variables of the interest. So set the parameters, okay, of like the mass of the pipe and the value for the theta, and then make into the acceleration vectors, which will be used for the calculation. Click on the run, and you're going to have the output. Once again, everything here is just snapshot from the code itself, just still defining the equation and compare them to the one that we had already listed above in the tables. Okay, just remember once again, you will need to run initially every section of the code individually. Don't run the whole code in one go. Convert to a simulating block. Okay, so instead of just having the MATLAB code itself, it already has been done. But anyway, I explained that in the video related to that work. So we have the block, and we're only going to do some connection between the output of the MATLAB and the input of the simulating code. Okay, and the task number 2 also has been explained here. Same way, define the parameters that we have, like the length of the code, the mass, the radius, and so on. Okay, and this will be the output. I showed you in the video how to get this output. I explained what these outputs are. So this will be the theta. You can see the theta will be changed between 10 to -10. That means the pipe is actually swinging. So it's going to go to -10, then it's going to go to 10, then -10 and to 10, and pass it by the value of the theta to be equal to 0. That will be the value for the theta in degree, that the same one just came down. Okay, and this will be the reaction to the x direction, and this will be a reaction to the y direction. By the way, 1, 2, 3 are the same. Okay, these two are different because one of them is going to be horizontal, the other one is going to be the vertical. The resultant of these values should give me the tension in the cable. Okay, yeah, well, they did zoom, and this actually to expand the thing. Everything has been explained here, and explained also in the, I don't know if they still have the PowerPoint, but I explained that in the video that I when I went through the code. You can find it in the playlist. Okay, so that's the CAD model. You can take a snapshot for it. You can make a video and upload the video to YouTube, and you can simply put the link. So you say, for example, that to see the video for that, click on that link. So instead, for example, instead of saying here the figure number 1, the swinging of the pipe with the cable, you can click also. You can put a link here to see the animation of the work. Click on that link, and it's going to take us to YouTube. Then we can see further animation of the work. Okay, so just keep doing that. Do the using of the brain and YouTube model and the Simulink model here, and compare files with the implement of the brain. Just keep describing the results and make a discussion about each. Okay, and that's it. That's the only thing you need to do. Just keep doing that, changing the parameters, and you will get different answers. Oh, this will be task number 3. Task number 3, we're going to have this block to be slide or no slide. So we're going to have the friction between the block and the surface, as this pendulum is going to be swinging. Okay, so yep, what we have to change here, because we have only slider for the theta, and this will actually the theta value will change all the other parameters, because the bigger the theta is, the bigger the port is going to be. Okay, I just want to make this, we don't talking about the project now. We're talking about the report. So this is very good one, very rich with the information. That's what I actually like to see here. Maybe they only had some missing with changing the parameters for more iteration than it's required. They just did less than what's required. Okay, so that's it. That's a very good one. Actually, that's very rich. Christina did very well job. That's the results, and the discussion of each should come at the end, which is that one. Okay, just make a discussion about that and done. So I will complete the virtual lab later. Okay, I'm going to stop